A moment ago, I was watching a football match and I thought, what if I predict the match before it even starts? Now look, I'm not a football analyst. I'm that saw one World Cup and now I have opinions kind of fake fan. But I couldn't shake the idea. Could I really build a model that predicts match outcomes? No experience, no plan, just vibes and self-delusion. Let's go. So I searched on YouTube and found out we could predict matches using machine learning models. I decided to stick with a simple one, the decision tree model. How does it work? Suppose you want to predict something simple, like, will we play football today? Or not? The prediction depends on a bunch of factors. Is it sunny? Is it raining? Do we even have time? In a decision tree, all of these questions start at the root, the top of the tree. From there, the model begins to split based on conditions. Let's say it starts with, do we have time? If not, we don't play. If yes, check next. Is it raining? Or it's sunny? If raining, how extreme the rain is. If it is extreme storm, we don't play. If it is just rain, we play. And if it is sunny and extreme hot, we do not play. If it is sunny and moderate climate, we absolutely play. And done. Our model is ready. Now, if you want to predict something, just hand this model your current condition, and it'll figure out whether you play or you don't. But hey, we can represent this decision model in many ways. For example, like this. But there's a problem. We've got a branch repeating on both sides. That's like doing extra work for no reason. So, what do? We calculate something called entropy. Entropy gives us the value of each node, and we use those values to figure out which question should split the tree first. Less confusion, more clarity.
Okay.
Now, let's predict football outcomes using this. First task, pick a league. And out of this European leagues, I went with LaLiga. Why? Because the few players I actually know are in it. And that's enough science for me. Next, I needed data. Had a few decent options. Understat. Amazing visuals. Footballdata.co.uk. Most used and reliable. Or FBref. I went with FBref. Don't ask me why, I just liked the vibe. Used the score data library to scrape all the football data I needed. Now comes the hardest part. Cleaning that data. Fixing missing values with weighted averages. Removing unnecessary columns. Encoding days, team names into numbers. It was just left and right. Fix after fix. Somehow it got ready, and I'm praying it too on the model. All right, it's time to build our very own decision tree model. Sure, we could just use the good old scikit-learn library, one line of code and boom, you've got a working model. But nope, I had to go down the rabbit hole and do it all from scratch. And now, here we are. Finally ran the model, tested it, and it's doing a pretty good job. Almost 95% accuracy. So, let's try it out on a live match. Las Palmas versus Valencia. Prediction, draw. Actual result, yeah. Valencia won. All right, time to fix some stuff.
One eternity later.
Cleaned up the data, and I upgraded the decision tree to a random forest. It is decision trees on steroids. It has multiple trees with different features and selects most common output from this model for more stable predictions. Built that from scratch too. Got some errors during testing. But hey, fixed that too. The model now gives 97% accuracy. Time for a real-world test. And, embarrassingly, not great predictions. At this point, I was desperate, so I added ELO ratings. I also tried a bunch of other models. They gave me insanely high accuracy, but the predictions? Garbage. Later, I realized the real issue wasn't the model. It was the data, full of missing values, incorrect entries, and honestly, too small to train a reliable model. It's already been 2 months me trying to predict the matches, and the current season has already been ended. So I scrapped it all, changed the data source, re-downloaded everything. But this time, I had a very high-quality data, and suddenly, the model finally started performing well with decent accuracy. Somehow, I managed to squeeze some % of improvement to this model. Now it is the time to predict the upcoming La Liga season. But a new team had just joined the league, never seen before in the training data, as the data is from year 2014 to 2025. And the new team is returning. After freaking 25 years, the last match they played was in 2000 and 2001 season. And there is no way that data will be useful. So I ignored it. Real Oviedo does not exist in my predictions. And here's what I found. A prediction of which teams will win or lose their first round matches, with prediction accuracy. Here are the results. And finally, the full season prediction. Each team, total points, and who's taking the trophy home for 2025 to 2026. If this prediction kind of makes sense to you, hit like. It's not perfect, just code, data, and a bit of luck. Football's unpredictable, and that's why we love it. See you next match day.